All right, so factoring. Review. The first one is about as easy a factorization as you're going to see. Okay, so I'm not going to run through a whole bunch. If you want to, why is it that? Why isn't it this? Or whatever. Check it over. Now, what should you do? Every time you factor something, the next step is to immediately check it. Okay? Because factoring is not an end in and of itself. This is not Math 10C, right? Where we said factor this, and you got marks for factoring, and then you're done. This is 30-1, where we say factor this, and then we're going to move on and do a whole bunch more work. So if your factorization is wrong, everything that follows that will be wrong. So this is going to have to lead with the 3M, and I don't care how you factor. You can have little boxes on there. You can do over the rainbow. You can do whatever. Okay. Nobody cares. You could do decomposition, guess and check. Don't care. Okay. What we're interested in 30-1 is that in the end you have a correct factorization. Okay. That's all that matters. All right. What are the numbers here? 3, 2, plus, minus. Here squared 9 minus 2. Yeah. Right? Very important that you check, just run a quick, usually the mistakes come in, you get the signs wrong. So you put a plus there and a minus there, and also you're going minus 7 now, you go, oops, right? Get the eraser out, fix it. What's the first step in factoring this? Common factor, yeah. Find the greatest common factor, right? So here, there was no greatest common factor, 3, 7, and 6. Here, you get a leading 1, so that's fine. But here, we've got this negative 2x squared. So factor it out. And then, what's left? So we've got x squared minus 10x plus 24. Now, as soon as I factor, I check. Negative 2x to the 4th plus 20x cubed minus 48x squared. Right? Because if I get a sign wrong here, one of two things is going to happen. Well, stuff is going to be wrong. Worst thing that's going to happen is this won't factor. Right? And all of a sudden then you're looking at, you get confused, it's a more complicated process. You start wasting time. Precious time, those 6 hours that we don't give you 6 hours on regular tests, right? Regular test is just regular class period. Okay, right, and you factor. Any questions so far? This course is easy. Okay. What do you call this next thing? D. Whoops. There goes a page. What do you call D? Starts with a D. Difference of difference of squares. You're going to see a lot of differences of squares. Oh, garbage can is the metal one at the top. The bucket there next to the wall is the recycle. Like juice can, juice boxes, pop, whatever. And the green one is for paper. Pizza boxes. If you're putting in pizza box stuff, make sure all the food is out of them. Okay. Okay, how does this factor? Yeah, 3p plus 2. So it's square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term. Right? Difference of squares. You see lots of difference of squares. What are we going to do in this next one? Oh, right. Notice, you got a common factor, right? Which is what? So x minus 3 is a common factor. So that's going to give you 100x cubed minus 36x. Then you could say, but I also have another common factor, which is 4x. So where are we going to write that 4x? Yeah, we'll put it up front, right? You don't want to really sandwich a 4x in between two sets of brackets. Okay, doesn't look so good. If you do, just throw it in its own set. So we got a 4x, we got an x minus 3, and then we got 25x squared minus 9. Okay, that's it. We're done, right? Are we done? No. What else is there? There's a difference of squares, right? So, so whenever we say factor, it means fully factored, factor completely. We don't say factor completely, it's implied. When you factor completely. So, what do we got? 5x plus 3, 5x minus 3? Questions on factoring? Seeing none. Let's see if this works. Why? Linear function. Determine the equation of each line in slope y-intercept form. So this is reviewing 10 and 20. In slope y-intercept form, y equals x plus b, and in general form, x plus by plus c equals 0. So A is the diagram, B is just a description of things. So with the diagram, what do we have to find? First, second, what do we have to find? Yeah, y-intercept and slope. Okay, what's the slope? Two. Okay, so for slope we use m, right? Because slope. So 2. How'd you get that slope? Rise around. Just count it off the graph, right? Find a point. Here's a point. Let's go up 2 over 1, up 2, right? Rise, up 2, run, right 1. Slope is 2. What's y-intercept? So b is negative 3. So the equation in slope y-intercept form is? Yeah, y equals 2x minus 3. How do we get that into general form? We're going to move the y, right? So it's got to be ax. We already got the 2x, so we'll go 2x minus y minus 3 equals 0. Move the y over to the right side. Then the left side becomes 0, and then we're going to swap the left and the right sides because we really want it to be equal to 0. Okay? If they're equal to each other, it doesn't matter which one is on the left and which one is on the right. Okay? Generally speaking, in general form, the A will be positive. Okay, you're going to make the A positive. All right, line with slope passing through. What do we do with this one? Well, unfortunately, that's not a y-intercept, right? So what we're going to have to do is use the point-slope form for the equation of a line. So the point-slope form is y minus y1 is equal to mx minus x1. Okay. Oh, at this point, I will reveal the secret to math. There it is. Right? Here's the secret to math. Formula, substitution, so come up with a formula. What formula am I using here, right? So in this case, I'm going to use the point-slope formula because I have the slope and a point. I'm going to substitute into the formula, right? So you're showing me this. You're communicating. Math is all about communication, right? Anything that's written, the multiple choice, the numeric response, it's like whatever. Like I would really like it if you showed your work. So any test I give you, I really want to see your multiple choice answers. I want to see your work. Sketch it out in the space provided if you can. If not, get an extra sheet of paper. Do it on there. Okay. The tests are all fully secured, which means you don't get to take them home, but they will sit in that filing cabinet. You can look at them anytime. Okay, you can come in at wise time. Occasionally they'll be handed back during class. You can sit and look at it. So, you want extra paper? Fine. It's just going to get stapled on the back. Okay. But it's really important if you're going to make a mistake to know what mistake you made. Like if I show you that and say, how'd you get B? You're going to look at it, you're going to try it again, you'll get the right answer this time. And you go, I don't know. I honestly don't know what I did to get it right. But if you show us some work, we can look at it and say, oh, see this? It's minus a minus, so that's got to become a plus. And, oh. You're going to learn from your mistakes. So y plus 1 is negative 2/3 x minus what? No, plus 10/3. Okay. And we got to get this 1 over here. What's 1? Why I'm asking. What's 1? Because what has to happen? The 1 has to do what with the 10/3? So 1 is 3/3, right? And you're going to subtract 3/3 from 10/3. So you get y equals negative 2/3 x plus 7/3, which is actually right. Okay, now we want it in general form. To get general form, no fractions. So we're going to go through and multiply everything by 3. Okay, so we're going to clear out the denominator. So 3y is equal to negative 2x plus 7. Now we're going to go into general form, which is equal to 0. We want a positive x value, so we're going to kick the negative 2x and the 7 over here. So we get 2x plus 3y minus 7 is equal to 0. Any questions? Remember, at any point, you can ask. All right, we're good. Let's keep moving. Algebraically determine. Okay, you're going to see those words a lot. Algebraically determine. So what does determine mean? Show your work. Good. So determine means show your work. So we have to, now algebraically determine means show your work, and you've got to do it using algebra, not using your calculator. Okay? That would be like graphically. On the diploma, if it's machine scored, which it all is, nobody cares if you use your calculator to solve something. But when they say as an exact value, calculators are not going to give exact values unless, the answer is 2 or negative 5/2 or something. But when the answer is root 17, calculator's just going to give you a decimal approximation, right? It can't help you there. So you have to algebraically determine. All right, so how do you get an x-intercept? What do we do?
Y 0.
Set y equal to 0. Good. Nice. Set y equal to 0. So we take the equation, 3x minus 4y. So 3x minus 4 times 0 is equal to 16. 3x is 16. X is 16/3. Okay, so the x-intercept is 16/3. That's an exact value. You cannot give 5.3. Can't give 5.33. I don't really want to see 5.333 ... I don't want to see 5.3 with a bar over top. So if we have exact values, fractions in its thirds, then just write it as like 16/3. Okay. How do you get the y-intercept? Set x equal to 0. All this comes into play, right? Like all this stuff. We're going to be doing this through transformations, right? We're going to say, after these transformations, where's the y-intercept, right? So to get the y-intercept, I'm going to have to set x equal to 0, right? And then follow through. Okay, what do we got? So we got 3 times 0 minus 4y is equal to 16. Negative 4y is 16, and y is negative 4. Questions? Okay, so x and y intercept, right? So review stuff. Determine the point of intersection. How do we get the point of intersection of these two lines? system of equations, right? So we're going to have to solve a system. You're going to be doing that in 30-1. We will occasionally have to solve a system, right? So a system happens when you have two equations and two unknowns, right? And in this case, the answer is a point, right? Like in above, the x-intercept is a number. The y-intercept is a number. The point of intersection is a point. So your answer has to be expressed as, open parenthesis, number, comma, number, close parenthesis, right? Okay, so how do we solve this system? So we have two methods, substitution and elimination. Anybody want to say what method would be best suited? Yeah, elimination, right? So substitution is used when you have an x or a y by itself, right? One x or one y. Because then you can solve for that variable, substitute in, and away you go. We don't have an x or a y by itself, right? So we either need to make the x's the same or the y's the same. So which one? Doesn't matter. Make the y the same? Okay, so what are we going to do to, let's call this equation number 1. What are we going to do to number 1? Times it by 2, right? Okay, so 2 times 1 is 4x minus 6y equals 15. Pause. Sorry? Yeah, I would. So just because I'm going to make the common mistakes, you don't have to. I'm making these so that you won't make them on your thing. So a lot of times common mistake is people multiply the left side, they don't multiply the right side. So you're multiplying everything. Okay, what do we do to number 2? Multiply it by 3. Or negative 3 if you want to get fancy. It doesn't matter. Just the choice becomes addition or subtraction. So multiplied by 3, we get 15x minus 6y is equal to 30. All right. Now what? So what are we going to eliminate, and how are we going to eliminate it? Yeah. So the y's are the same, right? They're both negative 6y. When quantities are the same, we subtract. Okay. If they were opposite, if we had a plus 6y minus 6y, we would add. In this case, we're going to subtract. Okay, so what's 4 minus 15? Negative 11. Okay, negative 6y minus negative 6y, right? Subtracting a negative, so negative 6 minus negative 6 becomes negative 6 plus 6. Becomes 0, so the y's are gone. What's 30 minus 30? So what's x equal to? 0. At this point, you get a little freaked out. What? 0? Wait, no, it can't be 0. Yeah, okay, it can be, and it is. Okay, it is 0. Okay, now what? So now we got x. What do we do with it? Yeah, substitute into one of the original equations. Okay, which one? 1 or 2? 1? Sure. Doesn't matter. It doesn't matter. It's going to even say no. So substitute sub 0, 4x in 1. Okay, so 2 times 0 minus 3y is 15. Negative 3y is 15. So y is negative 5. And what's the point? 0, negative 5. Okay. So that is your point of intersection. Right? It means 0, negative 5 is on both of those lines. So we kind of know it's on this line because we just substitute in to get that. Is it on this line? So we'll get 0, negative 2 times negative 5 will be positive 10. So it is also on the second line. Okay, so that's been checked. Okay, good. Questions? Comments? Moving on. From linear to quadratic. Given the quadratic function. Okay, so this is 20 level stuff, right? Spent a lot of time on quadratics, which is time well spent, right? Because we did a lot of our transformations on quadratics. Okay, that's where we first got introduced to transformations. So, and half this course is transformations. Okay, I mean, first unit for sure, but then everything else is still really transformations. Okay, which way does this open? To quadratic. Opens up. Vertical stretch factor is 2. Is it narrower or wider than the graph of x squared? Narrow. We're very seldom going to use that description when we do our transformation. Okay, but occasionally we will. Coordinates of the vertex are 1 and -6. The equation of the axis of symmetry is x equals 1. The range is that's formal set notation, the set of all y such that y is greater than or equal to -6. Okay. The max or min y value, okay, so which is it? Is it maximum y or minimum y? Minimum, because it opens up. So the minimum y value, so a minimum y value of what? Minimum y value of -6 occurs when x equals 1. Right? That's just the vertex in words. Right? And well, it's the vertex and direction of opening put together in words. How does that happen? How is that so off? We can't go on like this. Okay, the x and y intercepts. All right, how do you get the x-intercept? Set y equal to 0. So 0 is equal to 2, bracket, x minus 1 quantity squared minus 6. Okay, mark it, set, go. Solve. Get your x-intercept or intercepts. Okay, so there are the x and y intercepts. You can pause the video and look through that if you're watching this on video. So for the x-intercept, set y to 0. Isolate the thing that is squared, which is the x minus 1. Take the square root of both sides. Remember, square root of 3 is plus or minus root 3. Add 1 to both sides. There you go. And for the y-intercept, set x to 0 and just work it out. Okay, -4. Questions? Next, write the equation. Determine the equation of a so determine means what? Show work. With a vertex of -3, 6 that passes through the point -1, -2, write it in vertex form and simplified form. Okay. So how are we going to start this? Well, let's take the equation in vertex form, y equals. Okay, so we've got y is equal to a, x minus -3, quantity squared, plus 6. So I've got the vertex. Vertex form, the vertex is p and q. So I've got p and q. So I'm going to plug that in. Now I'm just going to simplify this a little bit. Y is equal to a, x plus 3, quantity squared, plus 6. Okay, now what? What do we know, what don't we know? What don't we know? A. We don't have any idea what A is, but we do know x and y, right? Because it passes through this point. So we know an x and a y value is going to make this true. When y is -2, x is negative 1. So we can plug that in there and work out a. Okay. So, go ahead. Work out a. Okay, so a is negative 2. Once you've got that, you now go back to the second line we wrote, which was the simplified form after we put it into after we put the vertex in, we simplified that, right? Y equals ax plus 3 quantity squared plus 6. Now we know a, so the equation y equals negative 2 x plus 3 quantity squared plus 6. So what do we know? Well, we know it opens down. We already knew the vertex. We know that it's narrower than y equals x squared. It's got a vertical stretch factor of 2. Right? So there is information from the vertex form. And, yeah. I don't know why that's that. Quadratic equations. So, the solution to x squared plus bx plus c equals 0 is given by the quadratic formula. X equals negative b plus or minus squared b squared minus 4ac all over 2a. This formula is on your formula sheet. So, you're going to get a Math 30-1 formula sheet, which will be in the booklet when you write the exam. Okay, it's a tear out page. You're going to tear it out. You're going to take your sticky label, which hopefully has the sticky on the right side, and stick that on the formula sheet. You put one on the booklet. There you go.
Put in simplified.
Oh, right. Well, not done yet. And we need the other form, right? Simplify form. Y. So now we've got to expand this, basically, right? Like square that. So y equals negative 2 x squared plus 6x plus 9 plus 6. Negative 2x squared minus 12x minus 18 plus 6. Y is equal to negative 2x squared minus 12x minus 12. Okay, sorry. So negative 2x squared minus 12x minus 12. All right, back to this. So the expression under the radical sign, b squared minus 4ac, is called the discriminant. The reason is that it discriminates. It tells you about the nature of the roots. So if the discriminant is greater than 0, what does that tell us about the nature of the roots? Yeah. Not just 2 real roots, but 2 distinct real roots. Means they're different. We know they're different because I'm going to be adding, like if b squared minus 4ac works out to 17, I'm going to go plus root 17, and then I'm going to go minus root 17. So I'm going to get 2 different answers. What if b squared minus 4ac is equal to 0? Okay, well, we actually still get 2 roots, but we call them 2 equal real roots. Okay, so there are still 2 real roots. Okay, that's going to come in later in the course. We're going to talk about that in the context of polynomial functions, which is the second unit, I think. And if b squared minus 4ac is less than 0, then there are still 2 roots, but they are 2 non-real roots. Okay, so always 2 roots. 2 distinct real roots, greater than 0, 2 equal real roots, it's equal to 0, and 2 non-real roots if it's state the nature of the roots without solving the equation. Okay, so how do we do this question? So first step is to get it into the form ax squared plus bx plus c equals 0. Okay, so we're going to have to expand, collect. So 9x squared is equal to 24x minus 32. So 9x squared minus 24x plus 32 is equal to 0. So b squared minus b squared minus 4ac is equal to negative 24 quantity squared. Okay, so b is negative 24. Minus 4 times 9 times 32. Okay, so need calculator. Oh, is that a attendance sheet somewhere? Everybody had a chance at this? What's 24 times 24? 576, maybe? Yeah. 36 times 32. I don't know, that's why they make calculators. I would have known you were. What's 4 times 9 times 32? How much? 1152. Okay, so that's equal to negative 576. So what are we going to say about the roots? 2 non-real roots. So here's the thing. If you work through a problem, if you get a problem down to a quadratic and you recognize that the discriminant is going to be less than 0, then you can say there are no solutions, right, if you're trying to solve something. So instead of going through maybe a whole big solution solving process, you could just sort of say, hey, you know, I looked at this, b squared minus 4ac is less than 0, therefore there are 2 non-real roots, so there's no solution to this problem. Okay, so that's a legit step. Solve algebraically, leaving answers as exact simplified values, verified graphically. Alright, so to solve any quadratic, it has to be equal to what? 0. Okay, so to solve any quadratic, first step, get it equal to 0. So 3a squared plus 6a minus 9 equals 0. Now, because that's equal to 0, we get to do something, which is what? We could factor out the 3. As a matter of fact, we can go a step further than that. We can divide both sides by 3, leaving us a squared plus 2a minus 3 is equal to 0. So the 3 can disappear. Okay. Now, if you're moving on to calculus, then you're going to want to factor that, and there are reasons for that, right? These are 2 different curves. If I graph this and I graph this, I'm going to get the same thing. But, well, sort of. I mean, this would be 2 graphs if I'm, whatever. Same solution. These 2 graphs are different, but they have the same a-intercepts, right? They have the same value of a that makes them 0. That's all we care about, right? So solving is, what is the value of a that's going to make it 0? So then we factor, right, a plus 3, a minus 1. And we get our 2 values, okay? And then you would verify that graphically, but I'd leave that to you. Oh, calculator-wise. You can only use your graphing calculator, okay? So those of you that are still carrying around your junior high calculator, it's time to put that away. And the reason is, some of those calculators could do some stuff that Alberta Ed doesn't want done, like simplify radicals. Yeah, simplify radicals. And so they're just not allowed. Okay, so just from this point forward, just use your TI. Okay, next one. What do we got to do? We say, does that factor? You go, no. Don't think so. Does it? No. Okay, can't factor. So you can try factoring for a little bit. I mean, if I'm solving a quadratic, my first thing is always going to be, let's see if I can factor this, right? And I'm willing to spend a little bit of time. And when it comes down to the point where I go, you know what, I don't think that that's factorable, then we go to the quadratic formula. So you don't have to, but I like to list my value for A, B, and C. And then I like to write the formula out, right? Even if, you know, it's on the formula sheet, even if I've written it a million times, I like to write it out. Because I know the secret to math, which is formula, substitution, answer. So here's my formula, right? Also what you're doing is you're communicating. So if I'm marking this, you're communicating to me, oh, I realize I got to use the quadratic formula to solve it. Here it is. Now I'm going to substitute in, and away we go. Also, if you make an error and you've written this down, then I'm a little more forgiving. Maybe you get a little half mark that you wouldn't have got if you just write it down without the formula, and then, you know, because I don't know why the mistake is there necessarily. So a mistake that might cost you a mark might be mitigated by writing down the formula so I can see what's going on. Okay, so what do we got? 4 plus or minus square root. So make sure the negative is in brackets. And that goes for that C as well. All right, now all we do is work it out. It's just number crunching now. 16 plus 40. Oh, what's the largest perfect square that goes into 56? Well, 4 does. Yeah, 4. Done. So it's got to be simplified, exact simplified value. So exact, I'm going to tell you this right now. If in a determined, in a written response question, if it says exact values and you throw a decimal in for good measure, I'm going to dock you half a mark. Because I'm going to assume you don't know what this question is asking for. So do not throw in decimals. I'll just be sure. It's not an English essay. If I toss in more stuff, maybe something will be right. Or social studies. Let me just toss in these facts that I heard on Jeopardy the other day. Exact simplified values, I see a decimal in the written, you lose a half mark. Okay, I got enough witnesses here. Okay, so if somebody comes and says, why did I lose a half mark? Because it said exact value and you gave a decimal, you don't know what that means. Okay, you have to indicate. It's not going to matter so much for you guys, but the next time around, there's written response on the math diploma exams. And they're going to be very tight on the marking. So if it asks for exact, you would lose that half mark. Okay, so if you decide I want to rewrite the diploma to get a higher mark next year or something, there is written response.
Can't you cancel out the 2's as well?
If you want to get it wrong. So it has to be a common factor. So here, this, and this are all divisible by 2. Okay, all divisible by 2. But in the one below there, there's a 1 in front of that root 14. So there's no factor. See, this could be written like that.
But you can also write 1 plus or minus root 14.
So now, I cancel that. Yes, don't. But yes, you could, but you won't. Yes, you could write 1 plus or minus root 14 over 2. Please don't. Okay. Nobody wants to see that, right? It's easy when the whole thing's over 2. Okay. But technically, yes, it's not wrong. I would not mark that wrong. If you then gave me the decimal, then I would say it. Okay. Oh, timing. It's the secret to math, timing. All right, so we will pick up tomorrow